Welcome everybody to the second PCB Investigator scripting tutorial. In the first tutorial we have seen how an asynchronous script in the script engine of PCB Investigator can help you to highlight certain pins. So in our example we highlighted ground and power pins. In the second PCB Investigator scripting tutorial I want to do a special DFM check. So we often are asked how to use the script engine to write an own customized check, for example for test points. And I thought that in this video tutorial it might make sense to show you how a simple test point check, so the distance between a test point and another test point, as well as the distance between the test point and other components, can be checked, and all the mismatches can be reported. So we will start by opening the PCB Investigator script engine. The script engine is included in this separate window, and it is possible to write C# scripts. So I will switch to my local script tab, and for the beginning I will add a new synchronous script. So it is a synchronous script because it should do one single check, so considering all the test points, and do the distance check, and then it finishes. So we call it test point check. Okay, so we already got a good template here giving us the basic function execute, which is the entrance function when our script is started. So what we will do is get a little space here. So the parent is the pointer to our main PCB Investigator window. So at the first call I will ask whether it is null, what should never happen, but I always ask it, or parent is job loaded. No, what is the function name? Is job is loaded. So if the no job is loaded, if there's no design open, we can't do any checks, so we will just return. So then we want to access all the single components on all the layers. So we suggest that we have a top component layer and the bottom component layer, and we want to do the check on both of those layers. And to get access to them, we need a step object. So this is the main data object within PCB Investigator, and we get it out of our parent, so we can say get the current step here. Of course, if the step is empty or is null, we can't do anything, so we return. What we also need is access to the matrix. The matrix is the data object which gives us information about the stack up. So I can ask how many layers are there, what is the layer name, what is the layer type. So I get all the information about the layer stack up, which is included in the matrix. And I also get it out of the parent, so I can say give me the matrix. And again, just to be very secure, if the matrix is null, I will return. Okay, so now we want to start with check the top component layer. So how to get the layer? First we try to find out what the layer name is. So we say give me the top component layer name, and we get this one out of the matrix with get top component layer name. So now we can ask whether it exists or not. So we can say if string is null or empty or white space, then we won't do anything. But if it is not empty or white space, we will do something special here. So we want to use this layer for the check. So to get the data objects on the layer, I have to now call or get a layer object. So this is my data layer. And this I get out of the step. The step is the main data content object of PCB Investigator, of the design. And here I can call the function getLayer, and I just have to give him the layer name I want. So now again, if the data layer is not equal to null, and I suggest that it is not just a layer, an iLayer object, it should be an iComponent layer object. So now I have my data layer object. Before implementing a function here, I will do the same as a copy paste for the bottom layer. So I call the bottom component layer. I get the layer name here by calling get bot component layer, and I ask whether it is null or not. I get the data layer. Okay. So now what to do with those layers? I will add a new function here. It is a private function, and I won't have any result given back, and I call it just check test points. Test points. So, and I need the component layer object, the data layer. So this will be my basic function for doing the check, and I call this twice for the top component layer and for the bottom component layer. Okay. First of all, again, what should never happen, but to be secure, I say if layer is null, return. Okay. So now I want to get all the components on that layer, and therefore I can write I can call a function which gives me back a list of iObjects, and this will be the all components, and it is called get all layer objects. So now I will iterate through them. And what is quite important here is I cannot be sure that it is a component object, as iObject is the base class, and therefore I want to be sure that it is a component, a real component, and I ask if element is an iComponent object. Okay, so then I will save this in an own variable, and I call it just TP component, and I cast it here. So, okay. Now I have to find out whether this component is a test point or not, and the basic way to do this is to check the reference name. In most cases, the reference name starts with a certain letter or with two letters, if it is a test point, for example, with TP. And therefore, I will define a parameter, a private const parameter, and I will just give him the name TP reference prefix. And so I suggest that the component reference must start with TP, and then it is a test point. So this is how I recognize the test points. So now what I will do is I ask whether the TP component dot reference, whether it starts with our reference prefix. So, and if it starts with the reference prefix, then it is a test point. So our component is a test point. The next step will be to check all components which are very close to this test point and check the distance if it is too small or not. So what I will need, of course, is to have two maximum distance values. So I would just use a private double and call it min distance So TP to component. So this is a test point distance to any component. And for this value I just take 40 mils. So this is 40 in mils because PCB Investigator internally always uses mils as the unit. And I define a second distance parameter and I call it TP to TP. So maybe we want to check a different distance if two test points are too close. So I will use 100 mils here. Now I want to find out which component is too close to our test point. And therefore PCB Investigator has a very nice function which says, let me just check here, get all objects in rectangle. So I can say, give me all the components which are close or which are contained in a certain area of the PCB. And to find out in which area, I can say I want the test point component. I want to get the bounds of it. So this is just a rectangle D, and it is our TP bounds. Now I will enlarge this rectangle to make it larger, to include the maximum distance which I want to use in my check. So I can use the TP bounds point inflate method, and therefore I have to enter two doubles, and in that case I want the maximum distance. So I need the maximum check distance, and this is math.max from our two distance values which I entered. So I can say this one and this one. And to be a little bit more secure, I will add 1%. So I make it a little bit larger than the maximum value which I'm looking for. And now I will inflate my rectangle by these value in all directions, so as well as in -x, +x, -y, and +y. So TP bounds is maybe the wrong name now, so I just call it check bounds. It's maybe better. So the check bounds is a rectangle which is around my test point, and it is larger as the test point rectangle, and it's so much larger that all components which are within this rectangle can cause an error, or can be too close according to our rules. So now I will make a new loop where I will iterate again, and I call it near object because it's near to my test point, and it is out of the list get all objects in a certain rectangle, and we will get all these objects within the check bounds. Okay, so again I will have to ask whether it is a component object. So I will write here if my near object is an iComponent object. So now we are sure that it is a component, and again I will use the same method here to cast it. So I will cast my near element into my near component, so I now have access to the component object, and of course also the test point will be in this list because the test point itself is also within this check bounds. And what I have to do now is, if the component reference from test point equals the reference of my near component, then I can just say continue, as I don't want to measure between the test point and the test point. So between both the same test point. So we now identified in a list all the test points and iterate through all components which are very close to this test point. What we now have to do is to make a concrete measurement, and therefore we need a polygon. So we have an iPoly class object which gives us the possibility to measure, to check for intersections, to union polygons, and so on. And this object can be get out of our TP component. So I will just I place it here. I make a iPoly class object and I call it just TP poly, and I can get it out of my TP component by calling get polygon outline. And there's a parameter, a boolean, which says, do I want to include the pins, or do I want to just have the body of the component? And in that case, I just want to have the component body. So I don't want to include pins. And again, for my near component, I will do the same. I will get the near poly by calling the get polygon outline from my near component. So now again, to be secure, I ask whether TP poly is unequal to 0, to null, and also my near poly is not allowed to be null. And what is always a good idea is to save someone from time to time. Okay, so now I can ask PCB Investigator to calculate the distance between our TP poly and the near component poly. So I would just say TP poly, TP poly, here that one, and give me the distance 2. And I see I must enter a second polygon, which is my near poly. And I will get 2 points by reference. So I have a referent from point and a ref to point. And these 2 points I have to define somewhere. So I will define it at the top of the function. So there's a from point, which is point depot empty, and a to point. So this function does not only return the distance, the smallest distance between the two polygons, in that case between the two components, but it also gives me back 2 points to x, y coordinates, which define the shortest distance between those two. Okay, so now I have the real distance between those, and we have two different cases again. So it could be that my near component is also a test point, and I can ask whether the reference again starts with my TP reference prefix. So if yes, we have the case TP to TP, and in our else case we just have the case TP to component, to any other component, to a capacitor, resistor, or whatever. So now we will check whether the distance is smaller than our min distance TP to TP. And in the other case, I have to check whether the distance is smaller than the min distance TP to what was it? Component, I think. Yep, TP to this here. Okay. So if this is the case, then we really have an error. So the component is too close to our test point. So now the question is what to do. So at the beginning we just want to give this test point, which is maybe too close to other components, we want to give it a color. And we want to give it a red color or orange color or a green color. So I will just make a bool variable which gives me the information whether the distances were all right or not. So I just save a variable which says has wrong distance false, and if it is the case, I will say it is true, and here also it is true, and I will also give it a color, so I will give the TP component an object color, where it is, object color. So for TP to TP, I give it just an orange color. For TP to any other component, I will give it a red color. And if this is not the case, so if the component fulfills all the needs, I will give it another color here. So if it not has a wrong value, then I just give it a green color. Okay, so I will save it here and I will try to compile it. Okay, we get a few errors here in line 54. Of course, yes, I have to cast it as an iComponent layer. So I was already asking whether my data layer is an iComponent layer. So I cast it directly here and then check it again. So now we build successful. Okay, so let's check whether it works or not. So I will load a design in PCB Investigator. And let us just take a look onto the component layer. So we have a lot of components on the top here, and we have components on the bottom side, and we have a few test points somewhere here in between. So for example, here we have a few TPs. So what I will do now is just to click play. And what do we see? So a few test points are red, and red is if they are too close to other components. Here is one green, so that means that the distance is alright to all the other components. A few are also orange, so in that case not only distance to other components might be wrong, but also distance from test point to test point is wrong. Yeah, and we see that a lot of test points here get a red or orange color, a few also a green color. Of course, the check value has a lot of influence here. So if I do, for example, the same with 25 mils and then start it again, we see that more test points, of course, get green. So when I know my exact requirements for a test point distance to other components or other test points, I now can just enter those here in these two variables in my script, run it again, and within less than a second, so it is very, very quick, I will get all the test points colored, and according to the color I know if it is testable or not. And what we also now can do is, if I not just want to have a color, but if I also want to have a short report about this, I can add a few lines more in my script and make it even better. For this reason, PCB Investigator offers a kind of report dialog. So it can be found in PCB Investigator and then PCBI Windows, PCBI Windows here, and there is a report dialog. And I just make a variable report dialog, which is from this type, and I want a header and a title. So I just give it TP check, and my header will be result. So I will pass this report dialog object via reference also to my checking functions. So a lot of copy paste here. Boop. And at the end, I want to open my report dialog and show it and give a summary here. And therefore we have a show dialog function, and what we need is a type. So we have here PCB Investigator and PCBI Windows, the report dialog, and there is a enumeration for the window type, and I want to have it modal. So it is a synchronous call, and it will wait here until the dialog closes at the end. So what do we do now here with the report dialog? So first of all, we will add a report line here and log. So report dialog append log. So we are now analyzing a certain layer, and the layer can be found in our layer object here, get layer name. So we will have an entrance about which layer is currently analyzed. So now we will add a few more logs. So in the case that we have an error here, and just to give the color only once and not more times, I can say if it is false, and only then I will set the color. But I don't want to break, as I want to report multiple components which could be too close to our test point. So I just give the color once, but I will append a log here, and maybe I will do it like this. I make a small arrow, and then I export the TP component reference name, which is wrong, and then I write short text like this one is too close to, and to which component. So we are too close to near component dot reference, and maybe I also want to export the distance that we measured. So I can export also our distance here, and distance dots to string, and I want to export it with 3, so 3 numbers behind the point. Yes, f.3, and yes, I write just it is mils as unit. So that's perfect. And the same message I can also report in this case here. Yeah, the append log has also the possibility to add an enumeration at the end, and I will do it also in that case. So again, Windows report dialog and the log type, and we make this as a warning. If we do not specify it here, it is just a normal log. It's whether an error or a warning, it's just a log. And in that case, we make a warning. So, and now if everything is all right, then we say the TP component is okay. And I won't specify anything here, so it can be only a log. Yes, and maybe we just add a small summary at the end. So I will add TP count integer variable and an OK count variable. So always when we have a TP, I will increase this counter here, and if the TP is alright, so if it has not a wrong distance, I increase the OK count here, and now I can add a short report line at the end. So I think it should be here, and I will append a log which is giving me the information that we have OK count of TP count test points are OK. Great. So let's compile it again, or save it first, compile it, and we have built it successful. That's great also. So again, I will just start it, and I get a report here. So we see that the component top was analyzed and there were 0 test points, and then the component bottom was analyzed. TP33 was okay. 38 was too close to the capacitor 381, so 24 mils, and we checked for 25 mils. A few others were okay, a few others had a problem. So in total, 10 of 41 test points are okay, so which is very, very few. But of course, the 25 mils which we used in our script for checking is just a value for demonstration. So you can enter each value which is according to your design rules. But what we have seen now in total is that it's quite simple to write an own script which is doing a check according to your own requirements. So even if PCB Investigator offers a bunch of DLC checks and analysis of different kind, it is also possible to write own scripts and own plugins to do special checks according to your own rules in your company, for example. And the best thing is that those scripts, so let's do it with the test point check here, we can also add it as a favorite. So I will add it as a favorite, and now it is here a test point check. CS is linked to our favorite tab, and I will be able here to change the icon. So I already searched for a component icon. I have a library of icons, so if you have this, you can add each icon which you like to set for the script. So I now have a small component here, and as it has a GUID also in the command, this script will be automatically registered within PCB Investigator as a button. So I will show it to you now. I will close PCB Investigator. I don't save those changes here, and I will reopen it. And now he says he has new commands available, and I will resize it to fit this video. So what I now have is a script tab where my test point check is included as a button, and I can customize the ribbon and go here and say it's not script, I call it own DRC or design for testing, DFT. And our test point check, I want to make a large button. So now I have my own DFT and a test point check here. So if again go to my design, activate the component layer here, and now I can just make a one click, get my report, and all the test points have the color that I defined in the script according to my rules. So as you see, PCB Investigator is very simple to be extended to new functions. So you can write own scripts, you can use plugin system to customize it, to automate quite complicated functions too. So this was just a simple way to do test point check, but you can also make, for example, a check saying the test point must also have a certain distance to drills or to the PCB edge. And all this is very simple possible with PCB Investigator scripting engine. If you want to take a closer look to this code, I also added the script which we have written here into the web tab. So our online script summary here, where a lot of scripts already are included and giving you some code ideas how to do something. And if I look here for a test point, I will find the test point check script in the DFM tab. So here is the code, and you can just simply download the script, modify it to your own needs, to your own rules, to your own TP prefix, for example, and then you have an additional check within PCB Investigator in a few steps only. So hopefully you enjoyed watching this video, and for more information please visit our website www.pcb-investigator.com. Thank you.